American Eclipse.
This is the Super Bowl event, right? And we're kind of in the parking lot for the Super Bowl. They're seeing the 50-yard line, all the play action. We're in the parking lot, and what we would see would be that cookie in the sky with a bite taken out of it, which would be interesting. But she was explaining the diamond effect. You know, she was seeing that lovely corona and the streamers coming out. That is why you go see this. That is why you get in the path. So I just went outside to see how dim our area looks at 92%. Looks like kind of an overcast day, like a thunderstorm nearby. But when I asked her, I was like, how quickly did it get dark? So they were at like 2%, and it was still light, but then you get down to 1, 0, that's when it got dark.
And I imagine those folks who haven't seen an eclipse before, something like this, witnessing it, experiencing it, really births a new generation of scientists. I mean, those young folks just might be so encouraged.
So we've got 12 million people in the path of totality. You've got probably over 100 million within a day's drive. Yeah. I think you're going to, encourage a lot of new people to get into science, especially the younger ones that have several more eclipses in their lives.
Well, and Florida specifically will have an opportunity at being directly in the path, particularly Gainesville, in several years from now, correct?
So we're looking at 28 years from now, right? So this will be 2045. We've got a spectacular opportunity for an eclipse to come down from Alabama, crossing St. Petersburg, Tampa, Orlando, some of Gainesville getting in on that. So we will, here in Jacksonville, have to drive a little bit further south, but it goes all the way down to Miami and then out over into the Bahamas. What's even more impressive, and I hope we're all around for it, is that it's going to last 6 minutes long.
Wow.
So
that's awesome.
This is going to be something where you really get the temperature dropping, right? It's not just this. This is an appetizer.
Right.
No, we're ready for it.
That's right. The Great American Eclipse coverage continues. We're going to be right back after the break. And we bring in Mark here, our meteorologist. So Mark, a lot of people don't understand just how fast the moon's shadow is actually moving on the Earth. I mean, it looks slow as we're watching this, but it's not at all.
Not at all. You know, when this thing came across Oregon, it was cruising at about 2,300 miles, so 2,300 miles. This thing would outrun a Concorde, right? So this is moving very fast, but then it actually slows down relative to the Earth's rotation. So you think about, if you were to stand on the equator, you would be rotating around on the planet's axis at 1,000 miles an hour.
Wow.
You go further north, that slows down. So here in Jacksonville, we're actually, right now, we are spinning around at 900 miles an hour. But we have the atmosphere, so we don't feel it. We've got nice hair because we're protected.
Right.
But that's why the eclipse, the shadow slows down as it moves over the central portions of the country, because it's getting to an area where the speed of the Earth is getting closer, matched to the speed of the moon. So what that means is that the eclipse gets a little bit longer. And so we have a variation in the time of the eclipse from like about 2 minutes along the West Coast to about 2.5 minutes over
Well,
the
it's interesting because we did see that in Oregon. They had about a minute 54 for totality. We're not going to experience totality in our area, but it's going to be 2.5 minutes or so. As we're looking right now at South Carolina as totality is being reached, I think that it looks very dark there. That's just the filters and things that are being used. It will get very dark there. What can we expect here? I know it's cloudy, because 90% seems like a lot.
It seems like a lot. You know, you would think it'd be very dark, but it's not going to get that dark. In fact, it would be like we'd have an overcast sky during a thunderstorm. Even if you're like 97%, you know, there's just that sliver of the sun, but that's enough sunlight where things are still pretty light. It's not until that first 30 seconds right before totality where things get dark really quick. And that's when everything starts to get very eerie. And it happens so quickly that the shadows bending around the moon actually cast shadows on the ground like slithery snakes. Wow. And then it gets pitch black.
The
and then
corona,
you see
right?
the planets come out, the corona. And that's a great opportunity for scientists to actually study objects that are closer to the sun that are typically blocked out. There's some asteroids there. They're called volcanoids. And we want to know where those asteroids are, right? But you can't always see them when you have the photosphere being illuminated. That's the part of the sun that we see. When we look up at the sky, we're not seeing that corona. that's always hidden because the sunlight is coming, the photons from the sun are coming, and it blocks out that corona. So here's an opportunity for scientists to look and actually see Mercury, because Mercury is so close. We want to know what it's made of. We want to know, and even to this day, we don't exactly know the composition of Mercury. So NASA is actually putting up some jets, these 2 very fast jets that were used to actually watch the shuttle land. And they're going to fly those.
It kind of brings me to my next question. We were talking about the past discoveries. I mean, what has been learned from the past eclipses from a scientific standpoint?
Yeah, you can go on and on. I mean, that's what science is here. It's observation and making those observations, doing experiments to find out what's happening. And one of the biggest things was Einstein's theory of relativity was really supported by the fact that once there was an eclipse, you could see light get bent by the sun. And so it supported all of what he wrote down. His equations were saying, you know, the mass of the sun, the gravity should actually bend light in space-time. And then in the eclipse of 1918, they actually found that that was the case, and because they could see a little bit of a shift there in Mercury. So incredible when you look back at the science and what's come about.
And we'll see what happens in the future, right?
Well, absolutely. Yeah, and then also the history of it when it comes to the stories that were made up, like back in Roman times, you know, where people feared a solar eclipse, and you kind of used that maybe to an advantage when it was in times of war or fighting.
Well, you can kind of think of an eclipse as a peacemaker in some ways, because there was a scientist called Thales, and this was back in 585. And Thales, Herodotus wrote that he actually knew the timing of the eclipses, and so he brought both parties together and said, hey, you know, there's going to be an eclipse. Maybe we should make peace. Sure enough, there was an eclipse. They didn't have war because of that eclipse.
Hey.
You know, so hey, you know, maybe eclipses can bring all political parties together someday. I don't know.
Wouldn't that be nice? All right, Mark Hollins.
Maybe North Korea's listening, right?
Yeah.
Right, thank you very much for your perspective. We'll continue to get...
You know, the sun is kind of this chaotic ball of charged particles being fused together, but those appear to be notably cooler areas on the sun, and so we can use an eclipse like this to study where they come from or when they occur, try to get an idea of what their cycles are like and when they tend to be more prevalent, when they tend to be less prevalent.
And that's really important for our communications here down on Earth, because these sunspots can actually just cut loose from the sun, unfurl this hot gas, this charged gas, plasma, and these ions come into the Earth's magnetic field, and we see the aurora borealis, you know, the northern lights, which are spectacular. But also the space scientists are, you know, turning off the satellites, because our cell phones, all of our communications, the Channel 4 signal going up in the air, right? It works off those satellites. So sometimes if those go out, big problems, big costs. So it's so important to know exactly what's going on there with the sun and how things are happening.
Now that shadow exited South Carolina.
So it's out there. It took off of South Carolina's coastline at 1,500 miles an hour. So boom, out into the Atlantic right now. And it's slowly going to make it to the middle of the Atlantic, and then that's it. So it's just so incredible that here you have a moon that is 400 times smaller than the sun, yet it is 400 times closer, and it just blots out that sun like what we saw. It's truly inspirational, and I think all these young kids that are out there seeing this, you know, they've got a great future. 2079, New York City, there is going to be a sunrise eclipse. I probably won't be around, but these little kids will. Yeah. So that's something to really imagine over the Statue of Liberty.
Oh, absolutely.
That'd be incredible.
Yeah.
All right, thank you, Mark. And I know that you're here as our analysis certainly continues of this phenomenon.